Hello again, WHS students reviewing for your MCA. This MCA lesson is all about mutually exclusive events and finding probabilities for those mutually exclusive events. This is when we start talking about the possibility of a union or intersection of events. So let's go ahead and talk about what does it mean to be mutually exclusive. Being mutually exclusive happens or occurs if some event A and some event B cannot occur at the same time. So in order for things to be mutually exclusive, I guess I want to circle both of them, mutually exclusive, it means they cannot happen at the same time. So to be mutually exclusive means you cannot occur at the same time. It's this whole opposite things. In order to say yes, something is mutually exclusive, we have to say no, they cannot happen at the same time. Okay? Let's take a look at a Venn diagram and what picture-wise it would look like. Please notice these two circles do not intersect, which means these two circles cannot happen at the same time, which means that they are mutually exclusive. Okay? So this example is mutually exclusive. Yes, mutually exclusive. Some examples would be if you needed to pick a card. If we were talking about the probability of picking a jack or a 4, there is no way to pick one card out of the deck that is both a jack and a 4 at the same time. If we look at students here at WHS, if I pick a student and I say what's the probability that's a male or a volleyball player, there is no way for that to happen at the same time. I know that may disappoint some of you boys that we don't have men's volleyball here, but we don't. So as far as high school sports go, we wouldn't find a guy who plays volleyball. So those are mutually exclusive. They're not happening at the same time. Now, things that are not mutually exclusive. Okay? Not mutually exclusive means they can happen and they do happen at the same time. Notice these two circles overlap. There is a union, there is an intersection right here. This is an overlap, this is an intersection. These are happening at the same time, meaning they're not mutually exclusive. Let's look at some ideas. Let's look at another card idea. What's the probability? Okay, here's cards. If we go jack or a face card, is it possible for those to happen at the same time? You bet. Jacks are face cards. How about picking a female or a basketball player? Yes, at this school we have girls basketball, which means it is possible to pick one student who is both female and a basketball player. Those items are not mutually exclusive because they can happen at the same time. So, mutually exclusive means you cannot happen at the same time. Not mutually exclusive means there's some kind of overlap or intersection of the items. Okay, so in order to find these probabilities, when we're looking at events of one or the other, key word here is or, it's telling us that we're going to want to add. So to find the probability of events A and B occurring, we're going to simply take the probability of event A and add it to the probability of event B and subtract the overlap. I always like to think of it as minus the overlap, because the overlap is when events are not mutually exclusive, meaning they're happening at the same time. There's some kind of intersection there. So we always have to subtract that overlap. Now, if items are mutually exclusive, that means that there is no overlap. So we can simply take A plus B, because the overlap would be a 0. And does minus 0 do anything? No. So the difference between finding these probabilities is when they are not mutually exclusive, when there is an intersection or in some kind of overlap, we have to make sure we subtract that off. Okay, let's go ahead and give it a try. If you roll a 6-sided die, number cube, however you want to think about it, it says find the probability that you will roll a number greater than 3 or an even number. Okay, let's look at the sample space. If I roll a 6-sided number cube, it's 6-sided die, my possible outcomes are the numbers 1, 2, 3, 4, 5, and 6. Okay, so what's the probability of rolling a number greater than 3? So greater than 3 is my first event. Well, here's the numbers greater than 3. How many total options are there? There's 1, 2, 3, 4, 5, 6 different things that could happen. And to be greater than 3, there's 3 options possible. So we would have a 3 out of the 6 for event A, or, meaning add, event B, which says that the number is even. 2, 4, and 6 are all even numbers. So what's the probability that we would roll an even number? Well, that would be 3 out of all 6 options. Now, we are not done because we have to subtract the overlap. These events do occur at the same time, meaning there is an overlap, there is an intersection. Well, how many numbers were both greater than 3 and even? We should find that there are 2 of them. So we have to subtract this 2 out of 6. So we're going to take 3 out of 6 plus 3 out of 6 and subtract 2 out of 6. 3 plus 3 is 6, minus 2 is 4, so we get 4 out of 6, or we could reduce to 2 out of 3. So the probability that you roll a 6-sided die and you get a number greater than 3 or an even number is 2/3, or 4 out of 6. Okay, let's try the next one. It says you select a card from a standard deck of 52. Find the probability that the card is a 6 or a king. How many 6s are there in a standard deck of cards? Hopefully you know cards. There are 4 suits. So how many 6s are there? There are 4 6s in a deck of cards. And out of 52, that means we have 4 out of 52. Okay, so just select a 6 would be 4 out of 52, or means add. Selecting a king, and there are 4 out of 52 kings. Now, are there any cards that are both 6s and kings at the same time? And the answer to that is no. So I don't actually have to subtract anything, or if I write minus 0, it's not really doing anything. So if I add these up, I get 8 out of 52, or simply 2 out of 13 if I reduce. So again, these events were mutually exclusive because there was no overlap. Okay, let's try this again. It says you select a card from a standard deck. Find the probability that the card is a face card or a heart. How many face cards are there in a deck? Well, when we talk about face cards, we're talking about jacks, queens, and kings. That's 3. However, there's a jack, a queen, and a king in all 4 suits. So spades, clubs, diamonds, and hearts. So out of all 4 suits, there are 3 face cards in a suit, which means there are 12 total face cards in a standard deck. And then it says or, so we are going to add the probability of selecting a heart. Now, a heart is a full suit, and there are 13 hearts in a deck. So 13 out of 52. So a face card is 12 out of 52. A heart is 13 out of 52. Now, what's our overlap? How many cards are both face cards and hearts? Well, the answer is 3, because there is the Jack of Hearts, the Queen of Hearts, and the King of Hearts. That is 3 cards that are both face cards and hearts at the same time. So I have to make sure we subtract 3 out of 52. So this is the probability of a face card plus the probability of a heart minus the overlap, which tells me that there is 22 out of 52 for probability, or that reduces to 11 out of 52. All right, let's try one more with the rolling of the die. It says find the probability you will roll a multiple of 3 or a multiple of 2. So let's list our sample space again here. Okay, let's look at multiples of 3. That would be 3 and 6. So we have a 2 out of 6 option there. Multiples of 2, well, we have 2, 4, and 6, which would be or, means plus, 3 out of 6. Minus the overlap. What's an overlap? Well, that's when it's both of them, meaning a multiple of 2 and a multiple of 3. And the only one that was both was that one right there, meaning 1 out of the 6 was an overlap. So if we take 2 plus 3 minus 1, we again get that 4 out of 6, or 2/3. Okay, so that was mutually exclusive and not mutually exclusive, when events do occur at the same time and when they do not. Let's try it one more time, but this time let's try it with a table. So if I give you a table of information, in this case we're talking about people's blood types versus whether or not they are Rh positive or negative. If you are asked to find the probability that a donor would have type B or type AB blood. Let's go back to basics here. What's the probability you'd be type B blood? Here's B, and if you look at the total, 45 total people have B blood. Out of how many total donated? 409. So the probability that somebody would have type B blood would be 45 out of 409. And then it says or. So what do we do when we say or? We add and subtract the overlap. So we're going to add that to the next event, which would be the idea of somebody having AB blood. So what's the number of people who have AB blood? Let's look at our table. AB total. 16 total people have AB blood out of the 409 total donors. So that would be 16 out of 409. And when we do or, we have to think about the overlap. Are there any people who have both B and AB blood? The answer is no. You only have one type of blood, so there is no overlap here. So we don't have to subtract anything. If we subtract 0, it doesn't change anything, and we're simply left with 61 out of 409. Let's try the next one. Find the probability that a donor has O blood. So type O blood. There's 184 out of 409 total. Or means add and subtract the overlap. Somebody is Rh positive. Now for Rh positive, we actually have to look over here. So for positive, how many total people were positive? 344 out of 409. However, we have to remember we need to subtract the overlap. Subtracting the overlap. So is there an overlap here? This time, yes. Is it possible to be type O and be Rh positive? Yes, actually right here. This number is both O blood and Rh positive. So that is our overlap. So we need to subtract off that 156 out of 409, which leaves us with exactly 372 out of 409 as our probability that somebody has both type O blood or is Rh positive. Okay, that's it. So some things I want you to remember. If you're looking for probability and you are asked to find the probability of this or that, what you need to remember to do is that you're going to have to add and subtract the overlap. Okay? If you have A or B, you're going to need to take the probability of A plus the probability of B minus the overlap. Okay? Keep that in mind and hopefully you'll do fine. Just remember, sometimes there isn't an overlap because those events are mutually exclusive.